if we connect two resistors to a source of voltage, then the voltage in each resistor will be different. So for instance, we will have here voltage 1, voltage 2, but these two, for instance, will add up to build the complete voltage of the source, which is, for instance, a battery or whatever. And given this idea, well, we can actually work with Ohm's law and state that the current which is passing through the circuit times the resistance of the whole circuit, which is an equivalent resistance, is going to be equal to the current times the resistance 1 plus the current times the resistance 2. And since the current is exactly the same, well, we can actually state that the equivalent resistance in a series of resistors is going to be equal to, let's put it like this, the sum of each resistance. If the resistors are connected in parallel, what is going to happen is, well, the current has to take a decision. So the current in each resistor is going to be different. But we know that the total current is going to be equal to the sum of them. Current 1 that passes through path 1 plus current that passes in the second resistor, path 2, right? And the difference in voltage is going to be the same no matter what, because they are connected, for instance, to the same source. And if this happens, well, given Ohm's law, we can state that delta V over the equivalent resistance is going to be equal to delta V over resistance 1 plus delta V over resistance 2. And since delta V's are equal, we can cancel them. We can actually state that the inverse of the equivalent resistance is going to be equal to the sum of the inverse of the resistance in each resistor, such that the equivalent resistance is going to be equal to 1 over the sum of the inverses. So we know how to add resistances in parallel and in series.